The last method that I'd like to bring your attention to in 5.1 Day 1 is the use of common denominators with fractions. There are going to be some cases where the other examples that we had, the changing to sines and cosines and using the Pythagorean identities, aren't necessarily going to work, at least at the beginning when you see something like this. So what we're going to do here is use an idea of common denominators to combine fractions, because it's really not a nice thing to have two fractions separated out. We'd much rather have them together. If we're going to create common denominators in this scenario, what we'll have to do is we're going to have to multiply each of these fractions by something to make them have what the other one has. So I've got one minus sign over here, I've got one plus sign over here. So they don't have each other, we have to multiply by each other. So this one's going to be times 1 minus sign to get that to have the 1 minus sign. And if I do it to the bottom, I have to do it to the top as well. And on the flip side, we have to have the 1 plus sign over here. And so on this part, we're going to do 1 plus sign on both the top and the bottom. And so we've got to have that all kind of put together so we can have common denominators. Well, what that does is when we simplify, it'll expand out a little bit, but then maybe after a little while the dust will settle here. We'll have 1 plus sine x on the top. Now if I FOIL this out, 1 times 1, 1 times negative sine, sine times 1, sine times negative sine, that's a difference of squares pattern, and so the middle terms cancel, but what we end up with is 1 minus sine squared when all is said and done. Over here, the idea was that we got the exact same thing in the denominator for this one, 1 minus sine squared. After we FOIL all that, you can give that a try and see if that works for you. But then up here we have 1 minus sine. All right, once we have it to this point, notice that we are now at common denominators. We have common denominators in these two fractions. When you have common denominators, we are now allowed to add them together. So because we're adding those together, the common denominator will stay the denominator, so 1 minus sine squared in the denominator. And then on the top, we just do the addition. We have 1 plus 1 is 2. And then we have sine plus negative sine. Those cancel out, so it's just 2 over 1 minus sine squared. Once we get to that point, we can do some of the things. Now we're able to work with some of the stuff we were talking about earlier, specifically the Pythagorean identities. Notice that this is sine squared. If I go back to my Pythagorean identities, one of them that you'll see in these Pythagorean identities, one of them that involves sine squared, the only one that involves sine squared is this one right here. So I'm going to rewrite that one on my page just off to the side. Sine squared plus cosine squared equals 1. All right, so now that I have that, I look at what I've got right here and notice, well, it doesn't look exactly like that, but I might be able to change this into something that will allow me to simplify that, get rid of that subtraction. So what I'm going to do is subtract sine squared over here just to rearrange this identity, which gives me cosine squared equals 1 minus sine squared. Well, now that I have that, you might notice that 1 minus sine squared is all of this, and so now I can replace that one. With just cosine squared. So now next piece is 2 over cosine squared, and that looks a lot simpler. That's getting to where we need to be. Now, there are going to be some problems that they ask you, well, let's get this simplified down to something without fractions. So if I'm going to do that, then I might just split these apart and notice that this means the same thing as 2 times 1 over cosine squared. And if you'll remember in the last video that we looked at, well, 1 over cosine would be secant. 1 over cosine squared could be replaced with secant squared, and so that's going to be our last step in this case, is to say that this is 2 times secant squared, and that's going to be a simpler version of what we started with up here. So again, that's just another way to work with these identities, this common denominator thing. As I mentioned before, though, the sine cosine change is the most important. Pythagorean identities are the second most important, and then this is probably a distant third, and it'll fall among some other examples that we work with in the coming sections.